Okay, let's jump right into it. When you hear Big Bang, you probably imagine, well, a massive explosion, right? A single point, a huge blast, matter just flying outward into this infinite empty void. But what if that entire picture is just fundamentally wrong? In this explainer, we're going to completely dismantle that idea and explore a radically different interpretation from general emergence mechanics, or GEM for short.
Now check out the stark contrast here. On one hand, you've got the classic bomb in space concept. I mean, it's intuitive, sure, but it's incorrect. On the other hand, we have the GEM picture, a vacuum state crossing a crucial threshold. So, instead of debris flying outward like cosmic shrapnel, I want you to imagine a dark, unstructured field suddenly crossing a line where it becomes capable of holding geometry. We really need to shatter this idea of a pre-existing empty room, because literally, there was no outside space for the universe to expand into. There was no center, no pre-existing arena just sitting there waiting to be filled up. The whole concept of outside, that didn't even exist yet. So if it wasn't a giant bomb, and there was zero empty space to fill up, well, that brings us to the core GEM question guiding our whole journey today. If the Big Bang wasn't an explosion into space, what exactly was it? The crucial point is captured beautifully right here in this quote. The universe did not explode into space. Space became admissible as a coherent state. We're totally swapping out the concept of an explosion for the concept of admissibility. And definitely keep that word admissible in the back of your mind, because it changes the whole shebang. Section 1. Standard Cosmology Correction. Expanding the scale of space.
You know, standard cosmology actually already corrects this explosion myth. It tells us the universe began as an incredibly hot, dense state. And the key takeaway? Space itself expanded. Every single region of the universe was simply closer together. This expansion is literally the changing scale of space itself, not matter flying through it like debris.
Now, while GEM completely accepts that standard model correction, it takes things a step further and asks so much deeper geometric questions about the vacuum itself. I mean, if space itself is expanding, what fundamentally changed in that early state? What suddenly became possible? And really, why did coherent structure become admissible in the very first place?
Section 2. Phase transitions. Changing the admissible order. To answer those deep questions, we can actually look at stuff we experience every single day, phase transitions. You know exactly how this works with water freezing into solid ice. But it happens in high-level physics too, like when a material suddenly drops below a critical threshold and becomes a superconductor. The material wasn't simply pushed harder, right? Its fundamental structure, its admissibility, completely changed. And this quote right here perfectly captures why we have to rethink the Big Bang. A phase transition is not just motion, it is a change in what kinds of order the system can hold. Think about it. When liquid water becomes ice, it can suddenly hold a crystalline structure that the liquid just couldn't. The actual rules of what is allowed have shifted. Okay, let's map that same logic onto the cosmos. The early universe was this extreme state where particles, atoms, stars, and eventually minds were simply not yet admissible. The geometric conditions for their existence just weren't available. But after this massive phase transition, a coherent geometric field could finally propagate, cool down, and eventually support actual structure. Section 3. The coherence shell, the boundary of persistence. Now, this next part is a bit of a mind bender, the coherence shell. We're not talking about a physical wall floating out there in space. It's a constraint structure. Think of it as a persistence boundary, separating what can remain coherent from what just falls apart. When the early universe crossed into a shell-supported state, the first real question wasn't, where did the matter go? It was, can coherence hold it all? Because if the answer is no, everything just dissolves. No universe. That means the first successful structure was not a star, an atom, or a particle. It was coherence itself. Without that initial foundation of persistent geometry, absolutely nothing else gets built. Section 4. Modal theory and inflation. Finding a self-consistent mode. So, how exactly does coherence hold? Well, modal theory tells us that a universe is not just every possible random vibration. Most possibilities just cancel out or fail to close. A universe is a mode that actually closes on itself. It relies on really deep constraint structures, like the 255-degree attractor and Z3/Z2 closure geometry. You don't need to sweat the heavy math here. Just grasp the visual idea. Structure absolutely requires constraint. It's definitely not a free-for-all of endless vibration out there.
As this says, reality begins when possibility finds a self-consistent mode. It has to lock into a state that actually works and balances out.
So where does cosmic inflation fit into all this? Well, GEM doesn't throw out the standard inflation model at all. Instead, it reinterprets it as a rapid coherence release. It's less like a giant bomb going off, and a lot more like the vacuum falling into a new stability basin and doing so way too quickly for matter to even exist yet. It's a transition from a high-cost vacuum into a much lower-cost expanding geometric state.
Section 5. The persistent sieve, opening admissibility windows.
After that incredibly fast early expansion, the universe began to cool down, and it acted like this giant cosmic persistent sieve. We can actually track how this opened admissibility windows. First, as it cooled, fields stabilized. Then, field conditions allowed particles to become meaningful. As the temperature dropped more, nuclear binding became possible, forming nuclei. Then electrons could bind to form atoms. Eventually, gravity and pressure formed the stable basins of stars. And finally, chemistry became bounded enough to allow for life itself.
It's exactly like this quote says, "The early universe did not build everything at once, it opened admissibility windows one by one." Every single stage on that timeline asked one simple question: can this structure now hold? The universe didn't just dump all its contents out at the starting line. It proved that structure emergence is strictly dictated by these changing rules of admissibility.
Now, I want to be super clear here. GEM is not asking us to abandon the massive observational bedrock of standard cosmology. The cosmic microwave background, cosmic expansion, the light elements, all of that is totally solid. Instead, GEM asks if these established facts can be interpreted through a deeper persistence geometry. It turns cosmology into the grand history of what became able to persist.
People always love to ask, well, what came before the Big Bang? But if time and distance are actually part of this new admissible state, then before might not even be a valid concept. As this puts it, the Big Bang was not the universe throwing matter into space, it was the universe learning how to be space. It was the forging of the very geometry that currently holds your body and the device you're watching this on together.
We have completely dismantled that old explosion myth today and replaced it with this breathtaking story of a vacuum state opening windows of admissibility, one by one. So, as we wrap up this explainer, I want to leave you with this to ponder. Did the universe begin as a chaotic explosion, or as the very first successful act of coherence?